All right, ladies and gentlemen, welcome back. You're looking at part two of our naming unit. This one is dealing all with acids and then also covalent compounds. So last time we talked about ionic naming and how to get metals and nonmetals. Naming acids is probably the most difficult thing. It's the thing that people usually struggle with at the end. So let's get her going here. All right. So first of all, acids have an H in front of the formula. So for example, if you have something like this, you can tell that it's an acid because there's H. The other thing too, it always ends in aqueous. Aqueous. And so we put an AQ beside it as a subscript to show that it's an acid. What this means is dissolved in water. Okay, so it's just a solid that's dissolved in water. This was hydrogen sulfate dissolved in water. It makes it a certain acid. Okay, so let's look at the naming system. We have two that we care about. Okay, so we have H's and an element. We have H's and a polyatomic ion, which remember is on the back of our periodic table of elements. And we have H with another polyatomic ion. So let's look at the H with the element first. So for example, if you look at H2S aqueous, this S is an element, it's sulfur. So anytime it's just an element, we call it hydro, sulfur, and then it ends in IC acid. So that element, when this thing is by itself, to show that it's by itself, we put hydro in front of it. It's the only situation that's going to end and start with hydro. And then we end with IC acid. So let's compare it to H2SO3 and H2SO4. So both situations start with H. We know it's an acid. There's AQs after it, so we know it's an acid. This time it has, instead of an element, it has a polyatomic ion. So this is on the back of the polyatomic ion sheet, or periodic table of elements. This is on the back as well. So if you look at the names of SO3, the name of it is sulfite with a ITE ending. If you look at SO4, it's sulfate. So what we have here is two different situations. If you have a polyatomic ion with an ITE ending, like this one, it will have a certain ending. ATE have a different. So what we have is if it's an ITE ending, we write down the element, or the name of it, sulfur, and then we put the OUS acid. So if it has an ITE ending on the polyatomic ion sheet, we're going to give it OUS acid ending for its name. Compare that with this one. If it's an ATE ending, we're going to do the same thing, sulfur, but instead it's going to have the IC acid again. So as you can see, the only difference between these two is the hydro in front of it. So you see hydro, think of just an element. If there's nothing there, it's going to be ATE ending. So the way people think about this is if you eat acid or if you have something that's acidic, so if you ate it, it's going to be icky. Okay, ATE goes with IC. All right, let's look at a couple of these ones here. So this one has a hydrogen with an element, so it's going to be like the first one. So we write down hydrochloric acid because the hydro comes from here and the Cl would be chlorine on our periodic table. Okay, so I want you to pause this now and try the next three and see if you get these names. Okay, so hopefully you got these ones correctly, and if not, put a big asterisk there and we'll figure out why later. I'm going to erase this. Ooh, apparently all of it. And let's look at these ones. So as you can see, we already did these ones up above, so we can cross this one out. Try this one out yourself. Okay, so we have a phosphate ending, so it's ATE. So if you ate something icky, it's going to be phosphate, but phosphoric. We changed the ending. Acid, IC acid. Okay, so you can try these ones on your own. Go right ahead. So pause it now. So let's see if you got this one. It was nitrate, so it's going to be nitric acid. And this one's going to be nitrous acid. This is a tricky one. This here is an acid. It breaks the rule. This is the one exception. It's got its H ending. So this one is called, it's an acetate ion, so ATE ending, so it's acetic acid. So tricky, tricky, tricky. All right, so plugging away here, this last little bit is all about covalent compounds. Should be fairly straightforward because it's going to use the same prefixes as we did for the hydrates. So whereas 1 is mono, 2 is di, etc. So if you look at this, here's the steps. It consists of 2 nonmetals. They don't need charges. The only thing you use is the prefix. So for example, nitrogen, N, oxygen, O. How many of each of the elements? Di means 2, tetra means 4. There's the formula for it. If you look at bromine, Br, nitrogen, N, penta is 5, mono is 1, so we don't have to do anything. So what you can do here, I'll try this next one. So this is the opposite. So if it's P2, so P is phosphorus, oxygen is oxide, we do the same dropping of the IDE. Di is 2, and tri is 3. So try these ones out on your own. Pause it now. Okay, so this is what you should have got. And if you did not, chances are it was probably this one. You might have put monocarbon monoxide. Weird rule that if there's ever a 1 for the first element, we just leave the mono off. Okay, so hopefully that wasn't too bad, and we're going to do some practice in class.